Hello, this is Mr. Muller for Lesson 7-2, Powers of 10 and Scientific Notation. So scientific notation is used mainly for writing really big or really small numbers. You wouldn't use it to write like 1,000 or 10,000 or something like that, but when you're talking about, how far like the sun away is or how small like a cell is, things like that, where you're talking about really small numbers where you don't want to write out all those zeros. So we have scientific notation and we have standard form. So scientific notation is writing out those numbers with the 10th to the whatever power. Standard form is writing it, if I'm going to write 1,000, I would write 1, 0, 0, 0. So that's just the two kinds of numbers that we usually deal with in math. So like I said, scientific notation would be, writing 10 to the third power instead of 1,000, or 10 squared instead of 100. Or things like this, we probably wouldn't write, 10 to the second power for 100. We'd probably just write out 100. But maybe if we're writing out 0.001, might write 10 to the negative third power, because then we're starting to get down to some small digits here. So if it is a positive exponent up here, we're going to move that decimal 4 places we're going to move it to the right. And then depending on what the number is, then it's 4 spaces or 5 spaces or 6 spaces. If it's a negative exponent, that means we're moving it to the left. And in this case, we'd be moving it 6 spaces to the left. Okay, so 10 to the negative 6th power is what that's supposed to be. 10 to the 4th power, 10 to the 9th power. So 10 to the negative 6th power. So again, moving it 6 spaces, 1, 2, 3, 4, 5, 6. 10 to the 4th power is just 10,000. 10 to the 9th power is that number. Okay, so if I want to rewrite this, so 1 million, another way to rewrite that would be, so I know I have a 10 here somewhere, 10, and then I am moving my decimal over 1, 2, 3, 4, 5, 6. I could say it's 10 to the 6th power. Kind of the same thing here. So I'm moving that decimal over however many spots. So I know I have a 10. I'm moving it 1, 2, 3, 4. It's going to be 10 to the negative 4th. Alright, so just another way to write those really big or really small numbers. There's pretty much only one rule to scientific notation. If you ever see it where it's not to the 10th power or something like this, it doesn't have to be a power of 10. It could be 3.5 times 10 to the 11th. This first number here has to be between 1 and 10. So if you don't ever know where to put the decimal, if you get a number like 6,587, and I say write that in scientific notation, and you don't know if the decimal goes here, 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 or here, it always has to go after the 1 spot. It always has to be, the number has to be between 1 and 10. So this one would be like 6.5 times 10 to the 1, 2, 3, third power. There's only one way to do that. So you might say like, oh, well, Mr. Muller, I just wrote differently. I wrote 65.87 times 10 to the second power. That's not going to be right. The only way to write that is it has to be a number between 1 and 10. Again, this is supposed to be 10 to the 8th, not 108. Sometimes when I make the files, it doesn't like to do the exponents up top. So if I'm moving this 8 spots over, you already know that there's a mistake here because that's 23.89, not 2.389. So this wouldn't ever be a problem that you would ever do. Same thing here, 467 is not a problem you'd normally do. 4.67 is what it's supposed to be there. So it's a good way on MCAs. If you're ever doing a scientific notation problem and they give you an answer that says 23.89 times, 10 to the 8th power, well, right away you can cross that stuff out because it's never going to be 23.89. It would always be 2.389. Just another way that they're trying to trick you on those problems. Some other ways we might have to organize them. So, here we can probably tell that this 10 to the 30th power is probably going to be the biggest there. Moving that decimal over 30 spots is going to be pretty large. So that's our biggest number right there. Next biggest number, whoops, not cross it, let's underline it. So this one's going to be our biggest. Next biggest, we have 2 10 to the 14th power. So 4.5 is going to be bigger than 3. So that's going to be next. And then I have that one. Okay, so this is just how I do least to greatest or greatest to least problems. And now I'm going to look for the smallest one because now I get kind of confused with what's really going to be smaller. Well, I know this one's going to be the smallest because if I'm moving that decimal over 12 spots that way, that's going to be a super small number. This is going to be the next smallest, 5.2. And then this 4 is going to be the biggest of those negative exponent numbers.